Uh, Welcome to the live session on the course Integral Transforms and their applications. So, this is the first week of the session. So, I think all of you have gone through the first week content, which is already released in the website, which is basically on the Fourier transforms. So, and the first assignment is also given there. So, you need to submit the assignment in the coming week. So every weekend we will be having these live sessions. I will be conducting them. I will discuss sample problems which is related to that week content, and that may help you understand the concept better. Also, this will help you in any way, your assignments you have to submit, also your final exam that you can write well. So you can come up with, so what I will doing is I will come up with some demo problems that I will be show how to do in the class. Then if you have doubt in some particular problems or whatever the case, you can also ask them. So let us start now. So I guess all of you know this week content is about Fourier transforms, and first of all, I think I don't need to introduce it. You all may know that if we have a function f of x, its Fourier transform, which we may denote it as Fourier transform of f of x, which we can be evaluated as f of x e raised to minus ikx dx integral minus infinity to plus infinity. Depending upon the field, you may put some normalization constant. So here in mathematics we use square root of 1 divided by square root of 1 by 2 pi. In electrical engineering they directly is 1 by 2 pi. So depending on the context, the normalization constant may vary, but this is the basic form. And its inverse, which is basically, if you have, so let's say this we denote as f of k, then f of k times e raised to plus ik x dk minus infinity to plus infinity, again the normalization constant 1 by square root of 2 pi, you will get back f of x, which is basically inverse Fourier transform of f of k. So I hope all of you know this. This is the basic thing that we need to know, and if we need anything more than this, that I will be discussing when we are going through all the problems. And also I suggest all of you that before coming to this live session, you should watch the videos related to that week content, so that will be easier for you to understand, and if you have any doubts regarding that, you can ask those questions. So I suggest all of you first go through the videos before every week session. So so how I am going to conduct this session is that, so I will show a problem. Like, first of all, we begin with the first question, which is which of the following is or are the Fourier transform of the function which is given by f of x is equal to exponential of minus ax square plus 2bxy. So we have three options given. So I want it to be a like interactive session. So if you have any questions in between, you can of course stop me, and I will clarify them. Also, so here we have three options. I first want you to first try this question, and if possible, you can tell me the answer, whether it is A, B, or C. So I may give you like 1 or 2 minutes for you to try, because this is a like 1 hour session and I have some more problems to go through. So you can try, and I will wait for 1 or 2 minutes for your answers, and then I will start explaining how to do this. So in the meantime, I will write the formula again here. So if you have any suggestion, like I don't need to wait for 2 minutes, I can directly start explaining. If something like that is there, you can tell me, so that like I'm guessing you people are trying it out. That's why I'm waiting. You can see the options are differ by factor in the exponential only. Like here it is 1a, and here it is 2a, and here it is 4a. So you might also can guess, instead of doing all the way, you can guess which one will be the factor. So anyone have done it? Okay, you can tell the answer if anybody have tried. So no responses, so I think anyway I will start explaining this. So if anybody get the answer, you can tell me while I am doing it. Okay, so first of all we write the function, which is exponential of minus ax square plus 2bxy. Then we have to okay, I made a mistake here and nobody pointed me. That's actually raised to minus ikx. I just copied the function itself there. Okay, so I think now you understand what the mistake was. Like it's minus ikx, then dx, minus infinity to plus infinity, 1 by square root of 2 pi. So I hope you have watched the video. In that there is a section where this kind of a function appears, and how the professor did is that he completed the squares. So the same approach we are going to use here. First we combine the exponential terms. So a raised to minus x square plus 2bxy minus ikx dx. Then what we now need to do is, in the exponential we have to take out the minus a. Then okay, before that I will just write one more step without skipping. Minus a square plus taking the x common out of the next two terms, like x into 2by minus ik dx. Now we can take exponential of minus. So I am taking the a outside and writing like minus x square minus x 2by minus ik divided by a into dx. I hope this is clear. I am just taking the a outside common from the two terms, such that I divide this term with the a. Okay. Now in this term we need to do a completing the square thing. So for that, I hope all of you know what to do. I'm just taking that particular term and writing is like 2by minus ik by 2a the whole square, then subtracting the 2by minus ik by 2a the whole square. So I am just writing only this term which is inside the square bracket, which we can write like this by completing the squares, right? So now if we continue this integral, what we are going to get is 1 by square root of 2 pi, and it's minus infinity to plus infinity, exponential of minus a. Now whatever inside the square bracket I can write like here I have pointed, which is x minus 2by minus ik by 2a the whole square minus 2by minus ik by 2a the whole square dx. So which we can so now we multiply this minus a inside the curly brackets. So what will happen is I will open the curly bracket, so this will become minus a, and here it will come as plus a. I hope that is clear. So now the terms in the exponential I will separate like this. This is an exponential of exponential of a plus b kind of form, right? So I can write it like exponential of a times exponential of b. So that's what I am going to do now. So I'll split it like this. It's exponential of first term into exponential of the second term. Now the exponential of the second term, which don't have any x dependence, so that means that's a constant compared to the integration that we can take outside, right? So that's what I'm going to do. So which will come outside, exponential of a into 2by minus ik the whole square divided by 4a square. 1 by square root of 2 pi is also a constant, and now inside the integration is only exponential of minus a times x minus 2by minus ik by 2a the whole square dx. Now if you have watched the videos which is uploaded in the website, you might know, so some of you already know this is a well-known integral. Whatever the quantity come inside the argument, exponential of minus a, generally you can say exponential of minus a y square dy integral minus infinity to plus infinity will be square root of pi by a. So that's what we are going to use here. We will replace this integral with its value, which is square root of pi by a. Now if we cancel this square root pi, we can write it like 1 by square root of 2a times exponential of. So also remember in the exponential this a and 1 of the a from the denominator will cancel, then we will get it's 2by minus ik the whole square by 4a. So which is the solution. So if you see here, option C was the solution. I hope that is clear. If anyone has any doubt, you can ask me. I am audible, right? Okay, I hope this is clear. So I will move to the next question. Okay, so now we have given an expression like this this particular form of f that I am using to denote the Fourier transform. The question says that the Fourier transform of the function f is given by f of k, capital F of k. So then what will be the Fourier transform of this combination, which is like x raised to n times mth derivative of f of x. We have 4 options here, so you can try out. This is actually easier to do. It just uses the property of Fourier transform. So you can try out. I may give a minute for you to try. So if you found the answer, you can either tell me, or you can text in the chat box. So I may write the properties that we may need to use here. So nobody answered it, so let me answer this. So these 2 properties that we need to use here. Okay, I got an answer, which is option B. Anyone else? Okay, so let me explain it, and then we will see which one is the answer. So first of all, you need to consider this as a product of 2 functions, like the combination, the Fourier transform of x raised to n times d raised to m by dx raised to m f of x. Let's say this is x raised to n times this combination, the nth derivative of f, that we can think of as, let's say, g of x. It's another function. Then by the first property, we can write this as I raised to n d raised to n by basically the kth nth derivative of the Fourier transform of the function g of x. So we have g of x to be mth derivative of x, right? Now if you think, we want the Fourier transform of mth derivative of f of x, which we can use the second property. So according to which, so the other terms will remain the same. It's the only we need to replace what is inside the bracket, which is Fourier transform of m the derivative of f of x. So here if you think f in terms of h, we'll just use the property 2, by which it's ik the whole raised to m into Fourier transform of the function f of x. That's all. So now it is given that the Fourier transform of f of x is capital F of k, right? That is given. So that means this we can write as I raised to n by nth derivative of ik the whole raised to m times f of k. Now if we think actually I raised to m is a constant, right? So we can take that outside. So I raised to m, then I raised to m, then it's d raised to n by dk raised to n k raised to m f of k, which is I raised to n plus m nth derivative of k raised to m f of k. So which is indeed option B. So option D is the answer. Is that clear, or any doubt is there? Okay, so we'll move to another question. Find the convolution f star g of x if f of x equal to sin dx and g of x equal to exponential of minus a mod x for a greater than 0, x in the interval minus infinity to plus infinity. So options are given. You can try it out. I'll wait for some time. Meantime, I will explain what convolution is. Then I will start doing the problem. So f star g of x says the convolution of f with g is equal to f of y times g of x minus y dy integral minus infinity to plus infinity. So this we can actually write in reverse manner also, instead of I mean if you do a change of variables, substituting x minus y as a new variable, let's say x minus y as u, then in terms of integral x is a constant, so it's minus dy is equal to du. So if you do that, I can write f of y, give me a second, x minus y is minus d, then minus dy is equal to minus du, or dy is equal to du. So from here I can write y is equal to, again I made a mistake, sorry, it's plus u only. So dy is equal to minus du and y is equal to x minus u, which is substitute here. I can write this as f of y as f of x minus u times g of x minus y as g of u and dy as minus du. And also the integration limit for u become it's x minus y, right? So it's x minus infinity to x minus plus infinity. So for any finite value of x, you can see this lower limit and upper limit will turn out to be just plus infinity and minus infinity, and this minus we have here with the du can make the change the integration order from minus infinity to plus infinity. So now if you see this, by definition is actually um, g star of f of x. So f star of x, g of x is equal to g star of f of x for any practical purpose. So I mean, we can choose any function to be f and any other function to be g, so that we can evaluate the convolution. So this formula itself is enough. Anybody got the answer? Or? Okay, let me start explain. So here it's given that f is equal to sine bx and g is equal to exponential of minus ax. So and this formula is also equal to, as I explained earlier, is also equal to g of y times f of x minus y dy. Both are same. So because of the particular nature of the modulus is coming in the exponential term, I'm going to choose that to be like represented just in terms of the variable x or y alone, not like x minus y term. So it's easier to choose a second equation in that sense for that particular function. So then according to the second equation, I can write this minus infinity to plus infinity. G of y will be exponential of minus a mod y. That's all. F of x minus y will be sine b x minus y. Right. Then dy. I hope that is clear. Just using the equation 2, where I'm just substituting the value of g and f. I mean, you can indeed use the first equation also, but I mean, you may need to like work a little bit, like some modifications, some adjustments, so that you will get the final answer same for both the cases. But I hope this is easier to do, because anyway the modulus function has a property like which is I hope all of you know what modulus of y is, which is plus y if y is greater than 0 and minus y if y is less than 0. Okay, so that we can split the integral into two parts, like minus infinity to 0, where the modulus of y is just minus y, then sine b x minus y dy, then 0 to infinity, modulus of y is plus y, so sine b x minus y dy. So now this time you can like multiply minus a with the minus y, that will become plus ay, right? So that I am writing here plus ay. Now also you can do a substitution as let's say z equal to minus y, so that dz equal to minus dy, only for the first integral. So then you will have integral of e raised to minus az sine b into x plus z into dy is minus dz, right? So minus dz, where z is from because we have changed z to or z equal to minus y, the limit of integration will become plus infinity to plus 0. This is for the first integral only. Okay, now we can replace the fact that there is a minus here, so that we will make plus, so that the limit of integration will become just 0 to infinity. Okay, now the second integral we can write as such, because we don't want to change anything there for the moment. So sine b into x minus y dy. Now you know here in the first integral we have z is actually a dummy variable, right? So we can replace z with anything we want. we will get the same answer. So we can just replace z with the y. Wherever I had z, I just replace with the y. So now we can combine the two integrals together inside the same integration sign, where the common things we can take outside. It's e raised to minus ay, then sine b x minus x plus y plus sine b x minus y, then dy. Okay, so now we here we have sum of two sines, right? So we had to use the formula sine a plus sine b, which is equal to 2 sine of a plus b by 2 cos of a minus b by 2. So according to which we can write it's exponential of minus ay 2 into sine of, so if you add the 2 times, and we are going to get the sine 2 sine bx, sorry, and then the subtraction term is going to give by, then dy. Let me erase some of these parts so that we have some space to write the remaining part of solution. I hope those steps are clear, that's why I am just erasing it. Okay, so now if you see here, the term which contains x, which is actually a constant, so it's 2 sine bx, we can take outside. The remaining exponential of minus ay into cos by dy. So I hope you know how to do this integral. So if anybody wants to know, I can show. Otherwise I am just assuming that you already know this integral. So its value it's actually a well-known integral. Okay, so the integral exponential of minus ay cos by dy from 0 to infinity, which is equal to a divided by a square plus b square. So if you use that here, which is equal to 2 sine bx into a divided by a square plus b square. So that's the solution. So which is basically the option C, I think. Yeah. So option C is the answer, the convolution of f and g. So any doubt in this? Is this clear, or do you want me to explain anything more? Okay, good. So now I have another question. G of x is given as 1 by 2a times heaviside of a minus mod x. Then find f star of g in the interval minus infinity to plus infinity. So this is actually simple. So this is not a general answer. It's actually general answer. Like f of x can be any function. Only g of x is given to be like 1 by 2a times heaviside of a minus mod x. So I'll give 1 minute for you to try this. Then if you get the answer, you can inform me. Then anyway, I will explain it. So before that, I will just go through what heaviside function is. So heaviside function h of x is 1 if x is greater than 0, 0 if x is less than 0. So some definitions say x greater than or equal to 0 also to be taken 1. In some definitions that x equal to 0, it is defined to be half. So whatever the case, we will have a step kind of function. If you see x and y axis. So when x is less than 0, we have 0, and when x is greater than or equal to 0, its value is 1. Okay, so this is Heaviside function. Now also here mod x is there, right? So now we say or we want to see how the Heaviside of a minus mod x will look like. So we can write it like it's 1 if a minus mod x is greater than or equal to 0. This follows from this definition. Okay, replacing x with a minus mod x, and then 0 if a minus mod x is less than 0. So that's all. This also can take two values 1 and 0 depending on the locations or value of x. So now the conditions here we can tweak a little bit so that we'll get the regions appropriately. So if you see the first condition, which is a minus mod x is greater than or equal to 0, which we can write as mod x is less than or equal to a, if we just shift the x to the right hand side. Okay, and the second condition we can write as mod x is greater than a. This is like mod x is less than or equal to a. So now we have also know that mod x is equal to plus x if x is greater than 0, and minus x if x is less than 0. So we have this first region, that's mod x is less than a. What that means is that mod x is less than a means that x lies in the interval minus a to plus a, so that only mod x will be less than a for any a greater than 0, because it's already given. Okay, it's not given, but assume that a is a positive quantity. Okay, so that's what we are going to do. It's missing in the question. And the second region, which is mod x is greater than a, which means that x is greater than a and less than minus a, or outside this region. So in the xy axis, if I want to plot them, assume some positive a value. Let's say we have a here, and correspondingly minus a will be symmetrically in the opposite location. I have drawn it not symmetrically, but think that is actually a symmetric location, and we have 1 here and 0 in the y axis also. Now what the function says that if x is mod x is greater than a, so that means it's outside this region, its value will be 0, both on the left and right hand side. When it is inside this region minus a to plus a, its value will be 1. So this is a function which is given, but okay, with the scaling factor. The function given has a 1 by 2a to be a scaling factor, so that we can appropriately scale, but still it will look like a rectangular function. So this usually known as a top hat function, because it resembles a top hat, right? the area inside actually area inside this graph is actually 2a. Okay, but if we have scaled it properly and with the 1 by 2a, and if we have plotted exactly g of x, then the area of that will be 1 by 2a times which is the height times the width will be just 2a, so that area will be 1. So in the limit of a tending to 0, this function is used to approximate the Dirac delta function. I think you may familiar with the name Dirac delta function. It's already explained in the course lecture videos, so you can go and watch them. Okay, so I hope you have tried this problem. So anyway, I will go through it. Nobody have come up with an answer. So in case if you found the answer, you can at least put in the chat box also. Okay, if you don't want to somebody come up with an answer, says D, option D. Anyway, anyone else? Okay, so let me go through it, then we'll see is it correct or no. So I guess you remember the definition of f star g. F star g, the convolution of x, is f of y times g of x times x minus y dy integral minus infinity to plus infinity. Now we have the okay, this also we can as I mentioned earlier, can be written as f of x minus y times g of y dy. So I choose this definition, the second one, instead of the first one, because here also I have a function g of x which is looking a little bit complicated with mod x and all. So according to the second definition, I can write it like, so f of x minus y, f is a function which is not given, I will write like f of x minus y only. And now g of y, which is I can write 1 by 2a times h of a minus mod x, which will be here will be mod y, then dy. So the 1 by 2a is actually constant, which I can take outside, then minus infinity to plus infinity f of x minus y into h of a minus mod y dy. I hope you remember how this function was looked like, right? This was just so if you plot the xy axis for any positive a, so from minus a to plus a, only its value exists, right? So in all other regions its value is 0. So that means this I can split into minus infinity to minus a, then this function will come here, plus minus a to plus a, again the function will come here, plus a to infinity, again the function will come here, and from minus infinity to minus a and a to infinity its value is exactly 0. So this integral and this integral value is actually 0. Only remaining term is from minus a to plus a, the function f of x minus y times its value, the Heaviside side has its value 1 in this interval, so dy. So that means it's 1 by 2a minus a to plus a f of x minus y dy. Now which is not exactly looking like what we have in the option, so we need to do a transformation. So we can do x minus y to be u, let's say, then minus dy is equal to du. So then this integral can be written as 1 by 2a f of u with the minus du, where u goes from x minus y, right? So it's a x minus a to x minus a, which is 1 by 2a integral x plus a to x minus a f of u du with a minus sign. The minus sign will change the order of integration to minus a, so from minus x minus a to x plus a, then f of u du. Now you know you use a dummy variable, so anything look like this will be a solution. So option D, of course, that we have somebody already got the solution. Yeah. So yeah, I forgot to put 1 by 2a also. Yes. So option D is the solution. Now any question in this? I hope this is clear. This is actually easier one. I just took a lot of time to explain this. This is clear, or any fact I need to explain again? Yeah, good. Okay. So yeah, now we'll move to then the final problem, which I don't have any options. Yeah. Okay. Anyway, so you can try this for like 2-3 minutes. Then I will start explaining this. So if it is given that gt of x, like with this integral expression, then asking for the convolution gt of x with the gs of x, where t and s are some variables, x is another variable. Okay. So you can start working on this, because I already explained what convolution and all. So this is like a miscellaneous problem. It requires some more work than the other problems. So anyone want to say how to approach this problem? You can tell. So the function g has two variables, t and x. So anybody have an idea how to proceed with that? How to take the convolution? How will you write the integral expression for this convolution? Only this time. I meant in terms of the function g. It's like convolution of g with g itself, but the variables t is like a lot of parameters are there, t, s and x. How will you write it? Okay, we have around 10 minutes, so I guess I will start explaining how to do this. I don't know can I finish this, but anyway, let's see. So I will tell how to do it, then you can try it yourself. I may tell the answer also, so that you can verify are you getting that or not. Okay. So first of all, the gt of x is already given, so we just want to write gs of x. Okay, so just replacing whatever t we have with s, so 1 by 4 pi ks in square root and minus infinity to plus infinity f of so because xi, which is here dummy variable, I just want to use a different variable, so that probably the integrations will come together, it will not become complicated. So I just use a different dummy variable, let's just theta exponential of minus x minus theta square divided by 4k s d theta. So I think that is clear, right? We have the same function but written in terms of two different variables, t and s. Now gt of x, we are taking convolution with gs of x. So how will you write that? So like x is like x is a variable in which we are going to take the convolution. T and s are like variables which don't going to appear in the convolution integral expression. So it's like we have gt of y, then gt of x minus y integral dy from minus infinity to plus infinity. Oh sorry, this is gs. Either one of them should be gs and other should be gt. So because both functions are g, even if you use the other form, you will get something similar. Just the t and s will be replaced. But finally, because of the symmetry, you are going to get the same answer. Okay. Now we have to substitute the actual expressions for g, t and g, s in this integral expression. So that we already have here, right? We have here and here gt and gs. So that we are going to substitute here. So the outer integral minus infinity to plus infinity will be there. Then first we are going to put gt of y here. So it's like 1 by square root of 4 pi k t. Then integral minus infinity to plus infinity f of xi exponential of minus, because we are writing using the variable y, we have to write here it's y minus xi the whole square by 4k t, then d xi. Okay, this is just the part gt of y. Now the second part we have gs of x minus y. Okay, for that we will use this expression replacing x with x minus y. So that also we can write. Probably we will say a different color for that. So it's 1 by square root of 4 pi ks into integral minus infinity to plus infinity f of zeta exponential of minus. Now wherever we have x, we have to replace it with x minus y. So it's x minus y minus zeta the whole square by 4k s, then d zeta. So that also we wrote. Now finally, don't forget to put this dy that we had from the this integral. So totally we have 3 integrals here. This may look little complicated, but we can work around with this and simplify this. I don't have enough page after this. Okay, anyway, I will remove some of this and I'll try to write things here itself. So what we will do is we need to take changes the order of integration depending on the variables which depends on like the dy which is right now is in the outer integral, so we can move this integration to inside wherever only the variables of y appear, and similarly the other integrals which are inside, which is depending on the variable psi and theta, I can take it outside. Like we are just shifting the order of integration. So of course the 1 by square root 4 pi kt and 1 by square root of 4 pi ks, those terms are constants always, depending on every variable, all these 3 variables of integration, they are constant, so we can keep them outside always. So I will write them outside, like 1 by 4 pi kt, 1 by square root of 4 pi k, yes, then integral minus infinity to plus infinity f of xi I have correspondingly a d psi along with, I'm just writing it apart. Also another integration with minus infinity plus infinity f of theta with the variable d zeta just before that. Then whatever remaining, which are all function of all these variables, especially the function of y, which I am writing here, which is exponential of minus y minus xi the whole square by 4kt, also exponential of minus x minus y minus theta the whole square divided by 4ks. So I hope this is clear. Like any doubt in this, like writing the order. So we are writing in a way that so each integral is written next to next to the terms which are depending on it. Like we are just changing the order of integration, and whatever constant according to a particular integral, we are taking it outside of that integral. I hope it is trivial to do this. So that's what I did here. So now still we have to do some more adjustments to it. Especially we have to combine the exponential terms. So we'll just take them inside and group them together like y minus xi. So only thing now remaining is we have to just work with this exponential term so that it will become simpler enough. So this is this two exponentials combined. Okay. Now this exponential alone is appearing in this integral minus infinity to plus infinity. So this this expression we need to evaluate. So then we substitute that back here in the place of this entire expression. Then we can simplify it. So what you have to do is you have to actually expand all these square terms and group the y square terms, then whatever terms, because it's a minus b the whole square term, right? So you will get the terms of y square. So it's like y square times something you will get, then plus y times something plus some constant terms. Like that you will get whatever inside the exponential. Now you have to group this by completing the squares that you can write in terms of y minus something the whole square multiplied with some pre-constant. This you can do it, right? Basically completing the square. Then plus you will have some other constant terms. This way you can remove this linear term. This is, I hope you remember that we have done this completing the square. So once you do this, you can write it, this exponential term, as a like this integral, like exponential of some constant times exponential of some other constant y minus something square dy integral minus infinity to plus infinity. Now because the first exponential I told it's a constant, right, that we can take outside, and whatever comes inside we can replace. Let's say this is a constant a, we can replace it with its value, which I told earlier, which is this square root of pi by a, whatever was the coefficient a was. So if you do this, then substitute this particular value what in the place of this red circle, then you can take that combine with the other terms f of xi and f of zeta. You can evaluate this double integral. So I may tell the last expression what it will look like. You can try this yourself. Of course this is not very easy to do. I am just giving a miscellaneous problem so that you will have a flavor of all things, like completing the squares, doing convolution, doing the Fourier transform integrals, all of them coming together in this problem. So you can try this yourself. I will just write the last expression. So you will get something like 1 by 4 pi k s plus t. Exponential of minus 1 by 4k into x minus theta minus psi the whole square into f of zeta, f of psi, d zeta and d psi. So this is how it look like. Now you can again go ahead and use the fact that gt of x is defined like this, so you can actually represent this as a convolution like minus infinity to plus infinity. It's actually g s plus t of x minus theta times f of theta d theta. Yeah, which you can write like it's a convolution between g s plus t of x and f of x. So you can try this out. Any doubt in like I haven't explained it full, but I have given the details how you can proceed and do it. So any doubt in that? Okay, so any other doubt regarding all the problems that I have done here? Also anything regarding like Fourier transform, the first week content that we have discussed? Okay, then I hope you all understood what Fourier transform and how to evaluate the Fourier transform, convolution, all the things related to this kind of problems. So I hope you are already have access to the assignment for this week, so you can start working on them, and you need to submit by the coming week, I think. Okay, so thank you all. So we will meet next week. Okay, bye.